Unit 6, Day 2 notes. Today we're going to discuss parallel lines and their proportional parts. There was a minor typo on the first question, but it should read, the triangles are similar, so solve for x. Well, let's first label all the corresponding angles. So I know right off the bat I have a pair of vertical angles right here. And then, since it's parallel, the alternate interior angles are also congruent. And lastly, these angles are also considered alternate interior. So with that being said, we know that this this x plus 5 side is proportional with the 15 side. So we can write our ratio, x plus 5 over 15 is equal to 4 over 5, because those sides are also proportional. And now we must cross multiply. So that's going to give you 5 times x plus 5 equals 4 times 15. This would give you 5x plus 25 is equal to 60. Subtract 25 on both sides would give you 5x is equal to 35. And divide both sides by 5, x is equal to 7. Now let's talk about the new stuff. Today we're going to, again, talk about parallel lines and their proportional parts. The triangle proportionality theorem says, if a line is parallel to one of the sides of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So in this picture, it shows you that segment BE is parallel to segment CD, indicated by the little red arrows. Since those are parallel, then we know that AB, which is here, is proportional to AE. So you could also write it like this: AB to AE. And then you could say is equal to BC over ED. That's one way of doing it. Another way of doing it is as they did here, where they put AB to BC is equal to AE to ED. That's another way. There's another one in there as well. BE is also proportional with CD or DC. So there's a lot of things going on here, a lot of proportional parts, and there's a lot of combinations of each one. You could even say that AE on the smaller triangle is this one side. So for the larger triangle, it's AD, which is the same side. It's proportional to AB on the smaller triangle and AC on the larger. So that's another possible setup. But what also helps is if you can pull apart the two different triangles to solve these. So the first few, that's what I'll do with you all. So let's do that first. Pull apart the triangle into two triangles. So you have Q, R, U, and you also have Q, S, T. Again, sometimes it's so much going on the picture that it's hard to determine that. So it's okay to separate it. Now I'm going to label the given information. It tells us that RQ is 8 and RS is 6 and UT is 9. So you have several ways of going about finding the length of QU, which we call the X. One way to do it is to notice that, again, QR over RS is going to equal QU over UT. That's one way of doing it. Or you could say that, again, this is X, QU, of the small triangle. QS is equal to 8 and 6, which is 14. And then QT is equal to X plus 9. So one way of doing it, or another way of doing it, should I say, is to set a proportion like this. You could have 8 is to 14 as X is to X plus 9. So you have several options, but which one looks easier right now? Yeah, it's the one on the left. So QR is 8, RS is 6, QU is X, and UT is 9. So that is an okay proportion to set up. You would still get the same answer if you used the right side. So let's cross multiply. 6 and X makes 6X. 8 times 9 is 72. Divide both sides by 6, and X is 12. Thought so. Now this one, it might be a little more difficult to see Well, actually, there aren't any triangles, but there's two sets of trapezoids. We have a trapezoid right here, and then you have another trapezoid right here. But regardless, you have three sets of parallel lines, and the parallel lines, as always, make proportional parts. So that means we could say x is to 120 as 210 is to 140. Or you could say x is to 210, compare the two on the top as 120 is to 140. So you can do proportions that are similar to based off of location as well. So there's a lot of different proportions that are possible. So again, the one on the left, I did top versus bottom on both sides of the equal sign. However, on the right, I did top over top as bottom is bottom. But also notice I did top left and then top right. And then I did bottom left over bottom right. So basically my two lefts are at the top, my two rights are at the bottom. So you can't mix up the two. You can't have a top left and a bottom right on top of each other. No, that doesn't work. So there are specific ways to write the proportion, but these are two options, and you'll get the same answer no matter what. So now, again, I'm going to cross multiply, so that's 140x is equal to 210 times 120. Which would give us 25,200. Then divide that by 140. And that's 180. So x equals 180. On this one, MN is parallel with YZ. I'll help you label it, but then you would need to find the missing piece. So we know that XM is 4, XN is 6, NZ is 9, and it wants you to find XY. So we'll put X. XY is the long length. So you have, when you if I on this one, I would probably pull apart the triangles and separate them if I were you. So I'll help you do that. So we would have X, M, N versus X, Y, Z. So again, XM is 4, XN is 6, NZ, NZ is 9. We're looking for XY. So we know what NZ is, we know what XN is. We could use that to find the total for XZ, which would be 15. Now you can set up a proportion to find XY. All right. Again, D is parallel to AB. We know that CE is T minus 2. EB is T plus 1. CD is 2. And CA, which is the total here, is equal to 10. It wants us to find T first and then the length of CE. So you have several ways of finding this problem. You could find what AD is because you know the grand total is 10 and you know that CD is 2, so that means AD has to be 8. That way you could say CE is to CD as EB is to DA. So CE top is to CD top right as EB bottom left is to DA, which is bottom right. So CE represents top left, CD is top right, EB is bottom or top left. Okay, rewind. I have my triangle flipped over because I'm used to the smaller one being on top. Okay, CE is bottom right, CD is bottom left, EB bottom right, top right, DA is top left. So that's one way of saying it. Or you could do right over right or left over left. So that's AD over DC is equal to right over right. So BE over CE. Or you could look at it as two small triangles or two separate triangles. So let's rewrite the triangles. Right triangle. So C, D, E, C, A, B. So we know that AC is 10. We know that CD is 2. CE is T minus 2. And then BC would be these two sides combined. So 2T minus 1 to combine my like terms. So that's another proportion that you can set up. So if I were you, there's really not an easy way to do this because just about all of them involve having to use both T minus 2 and T plus 1. So it really does not matter what proportion you use. So what I would do is say that CD is to CE using the smaller one, as AC is to CB, which means if I replace it with numbers, that's 2 over t minus 2 is equal to 10 over 2t minus 1. And now I have to cross multiply. So that's 2 times 2t minus 1. My t is starting with a plus sign now. 2t minus 1 is equal to 10 times t minus 2. Now I have to distribute, so that would give me 4t minus 2 equals 10t minus 20. Subtract 4t on both sides, so that's negative 2 equals 6t minus 20. Add 20 to both sides, which will give you 18 equals 6t. Divide both sides by 6, so 3 is equal to t. Phew! Now that we know what t is, we can find c by substituting it back in. 3 minus 2, so CE is equal to 1. You should be able to complete this one as well and take a photo. This concludes your notes for the day.